So I'm formally now starting the topic, and today we are going to understand the internal details once more, and we'll actually focus on learning the flag registers. Okay, so if you remember the diagram, if you remember the diagram of 8085 microprocessor, internally you might have seen there is a place where accumulator is there, and there is one more place that's called temporary register, and here you have flag register, and from here the arrows are coming like this, it's going to ALU, and here you will see two arrows like this, yes or no, and from here the result is going to the internal bus. I hope I have drawn the correct, yeah, internal data bus. So basically today what we will do, we will not focus everywhere, we'll only focus on very limited part. We'll try to understand only this section, okay, only this section, that how this ALU and flag register interact with each other, and what happens when the result is generated, what actually happens. If you remember in the last class I told you the result is divided into two parts. One is data of the result, and one is the nature of the result. I hope you remember this part. Okay, so we are going to analyze this section, and let's understand what really is happening in this section. Okay, so before making you understand that, let me tell you very interesting thing, that is, you might be like thinking that whenever 8085 microprocessor is accepting any kind of input, okay, this input is getting stored in some registers, yes or no. Okay, so you might be having some confusion that inside registers how data is stored, okay, how data is stored. So this is very important topic which I would like to clarify. So few of you might be aware, or I think all of you might be aware, that 8085 is a machine, yes or no, and machines generally only understand zeros and ones, yes or no. So this part should be very clear. Yeah, oh yeah, by only binary. So let's understand that, suppose if you look at any number, the number can be of two types. It can be a positive number, it can be a negative number, yes or no. So let's understand now first of all that how these numbers are first of all are stored in a 8085 microprocessor register. Okay, so keep in mind, suppose I am taking two numbers, let it be 7, I let it be one more number, let it be -10. Okay, so the way these numbers are stored in microprocessor is completely different. Okay, means in order to store a positive number and in order to store a negative number, the microprocessor is actually taking different steps for both of them. Okay, so I would like to now just focus on this part and try to analyze and make you understand how really these numbers are first of all stored, because unless and until you understand how the numbers are stored, we cannot do the ALU operation and we cannot go understand the result also. Okay, so let's understand first of all that how the positive number is stored. Okay, so positive numbers are directly converted, I mean whatever number you are passing, that will be directly the binary of binary digit. Like suppose if you want to pass 7, it will directly convert that 7 into 8-bit binary. So if you write binary 7, I mean 7 in 8-bit binary, it will be something like this. I hope I am correct. Yes, so any positive number, whether you write in decimal or hexadecimal, any way you write, the machine will understand that in a 8-bit binary format. Okay, I hope this is clear to everyone. Okay, so yeah, so if there is a positive number, it will directly take the binary of that positive number. Okay, but the case of negative number is not like that. Okay, so in the case of negative number, it takes 3 steps to store the number. So what it is doing, if you look at any negative number, what it will do, it will forget about the sign. Okay, it will not care about sign. What it will do, it will first of all take the data present here. Okay, and it will find out the binary of it. So if I say the binary of 10 will be what, can anyone guide me? Binary of 10. So I hope it is something like this. Just confirm me, guys. Yes or no? Yeah, okay, so if I write in 8-bit, it will be something like this. So this is step 1. Okay, first of all it will find the binary of this. Okay, then what it will do, it will do the first complement. So if you are not knowing about first complement, I am explaining here only. First complement means just reverse whatever the values are present here. So if reverse of 0 is 1, so the what it will do, it will get something like this. Okay, and after reversing, what it will do, it will add 1 to this. Okay, and by adding 1 to this, it is that is actually called 2's complement. Okay, 2's complement. Getting my point, guys? So it will, what it will do, it will add 1, and I'm adding and showing you 1 plus 1 is 0. There is a carry here, so this will become 1 and the rest will be copied like this only. So I hope I have written correct. Check it out. Okay, so this is actually called 2's complement. So keep in mind, if you want to store a negative number, the number will be converted into 2's complement, and then the number will be stored inside the 8085 microprocessor registers. Is this clear to everyone? I hope this is clear to everyone. Okay, so what I am going to do is I am going to take the help of this simple website where I will be putting some numbers and show you the 2's complement and all, so that we can analyze everything. Okay, so what I am doing now, I am just quickly, should I erase? I hope you have written this. Just a minute. Okay, okay, I'm giving you 1 minute time. In the meantime, what you can see here, see, if I write a number, let it be 12. Okay, and if I try to convert it, you can see as it is a positive number, I will take only this part. Okay, as it is a positive number, I will only consider this part. I'll add 4 zeros this side. Okay, and if this number is negative, okay, suppose I'm adding here minus 12. So in that case, what I have to do, I have to take the 2's complement. Yes or no? So you can see, if I convert into 2's complement, there I have this part of the result is giving me 2's complement. So what we will do, we'll take this part. I mean, we'll take the first 8 bits. It is given in 16 bits, but we will only consider 8 bits of it. Okay. So with the help of this website, I will be able to quickly generate the the binary value of a positive number and 2's complement of the negative number, so that we can process the result very soon. Okay, so I assume now that you all have done that. I'm just erasing this part. Okay, now what I'm assuming, if you remember in the last class, I taught you one instruction, that is a equal to a plus b. Okay, so I'll be executing this instruction inside the processor. So I told you in the last class that first of all, the a and b will be having some values. Okay, so what I'm assuming that, let's first of all assume that these registers are having some values. Okay, so what I will do, I'll first of all assume some values. Okay, so let's suppose that a is having 30. Okay, and b is having minus 40. Okay, so last class I also told you that the numbers will be stored first and then the ALU will start the per operation. So first of what I will do, I'll show you how this 30 and minus 40 is stored inside register A and B. Okay, so let's take the help of this software and find out the value of 30. You know that 30 is a positive number, so if I try to convert, I'll get the values. This I will be writing in 8 bits. So I can see here 5 bits and 3 zeros I will add. Okay, so quickly I'll do here. So I'll write 3 zeros first, and then there are 4 ones. Okay, and 1 zero. So I hope I have written correct. Just kindly confirm me, guys. I hope I have written correct. Yes, okay. Now what I will do, I'll take the help of again this software, and I'll take find the minus 40, and as you know, this minus 40 is a negative number. So what I have to do, I have to take the help of 2's complement. So this is the 2's complement. Already you have understood how to find 2's complement, but okay, so that's why I'll directly take the result from here. So I can see this is 41000. I mean, if I'll start from writing this way, 1000, and this side I have 1101. Just guys confirm me, 1101. Have I written correct or not? Just you can also check here. Yeah, I have taken these 4 bits, and then again I have taken these 4 bits. Yes. So inside microprocessor A and B register, these numbers will be actually stored in this format. Okay, so I hope now you are able to visualize actually what is stored inside the 8085 registers. Okay, now what I have to do, I have to perform the addition operation. So addition operation, what will happen, I have to add the bits. So 0 plus 0 will give me 0. Okay, then 1 plus 0 will give me what, 1. Then again I will get 1 plus 0 as 1. then 1 plus 1 will give me 0, and there will be a carry which will come here, and 1 plus 1 will give me 0, and I'll get carry here, and 0 plus 1 will give me 1. Now this will give me directly 1 and 1 and 1. So please just confirm me guys whether I have written correct or not. This is your result. Okay, I hope I have written correct. You can try yourself and confirm me, yes or no. I hope I am audible guys. Is it correct? Yeah, okay. Yeah, so this is the result which is generated. Okay, now if you look carefully, this result only we are going to analyze. Okay, so what I will do, I will now erase everything, and this result will be the prime importance of my investigation. Okay, so I'm going to erase this part, and I hope everyone has written it. Is it correct? I hope everyone has written. I'm erasing it. Okay, so I'm just erasing. Yeah, okay. So I hope everyone has written. So I'm just erasing A and B also. Just only the result which is important for me, that I am keeping here. Okay. And this result I will write on top. Okay. So the result is 1 1 1 1 followed by 0 1 1 0. Okay. So this is the result which I have got it. So I'll just erase this one. Okay. Fine. Now this result, what I said, the result will be giving me two kinds of data. One is it will give me the data, okay, and the second will be it will give me the nature, okay. Now what is the meaning of nature, that we are going to investigate, okay. So this nature is actually defined inside the flag register, okay. So the flag register, if you have seen, ALU is constantly always connected with ALU is always connected with flag register. How? You might have seen the arrow like this. Yes or no? The arrow like this. Okay. So constantly ALU is talking with the flag register. Okay. So let's understand what really is inside the flag register. Okay. And if you remember, I told you the flag register is a 8-bit register. I hope you remember this, guys. Okay, so this flag register is, yeah, it's a 8-bit register, but inside this 8 bits, actually all the bits are not working condition. Okay, working condition means all are not active ones. Okay, so I'll just do one thing. I'll try to first of all mark them. Okay, I'll take the indicator like 0 1 2 3 4 5 6 and 7. Okay, so these are, you can say, in the C language you might have studied about indices, array indices. So I'm marking like this. Okay, so these are the indices. So this 8th position is actually called 7th position inside the 8 in the registers part. Okay, so out of these 8 registers, out of these 8 registers, only 5 of them are in the working condition. Okay, it means out of, in the flag register, there are only 5 working bits. Okay, and three are deactive bits. I mean, 3 bits are not in the working position. Okay, so quickly I'll show you all the bits. Just wait a bit, and I'll show you in the PPT part. Just a second. Move to the PPT. Just I'll show you, and everyone has to note down this. Okay. Uh, is it visible to all of you, or it will be better? Yeah. So you can see here at bit number 7, S is written there. Okay. At bit number 6, Z is written there. I am just filling this so that we can again go back and start the analyzing part. So this is Z is written here. I also request everyone to write. Okay. So all of you please write down. I'll just change the color, and so that it will be easy for me to show. So I'll take the green color. Okay. So, and bit number 5 is a don't care bit. Okay. So I saw the 3 bits which are not working. They are also called as don't care bits. So bit number 4, it's written there AC. I'll write here. Okay. Then bit number 3 is don't care bit. Then bit number 2 is written there P, and this is a don't care bit, and this is written here CY. Okay, I'll come about these all, and you can even see that what these letters mean. Okay, better you write down also. The S means sign flag, Z means zero flag, AC means auxiliary carry flag, P means parity flag, and C means carry flag. Okay, I'm just giving you some time. Please, all of you write down what is the full form of these flags. And keep in mind, these flags are one bit flip-flops. If you remember, in the earlier class I told you about flip-flops. Flip-flops means what? A hardware unit which can store either 0 or 1. Okay, so these all flags which you are seeing inside, they are one bit flip-flops. And that's why if you look at the definition part also, it is saying that it contains 5 one-bit flip-flops. Okay, so 5 one-bit flip-flop means what? There are only 5 flip-flops and 3 are deactive, or you can say don't care bits where flip-flop is not present. Okay, so I repeat once more, there are 5 flip-flops and their flip-flop names are sign flip-flop, or you can say sign flag, zero flag, auxiliary carry flag, parity flag, and carry flag. Okay, so I hope everyone has written this. Just confirm me, guys, if you have written. I hope yes. Okay, now I'll directly move to the I'll move directly to the this part. Okay. So now if you look carefully, we were trying to analyze this part. Okay, so now we came to a conclusion that the flag is there are 5 flags and these are the flags. Okay, now if you look at this result, you know this result is actually having the nature. Okay, now whenever any result is generated, you keep in mind that these all flags or some of the flags will be you can say the value of these flags will be surely be changing. Okay, means they will be actually affected, that I mean to say. Whenever any result is generated, either one flag, two flag, three flag, or all the 5 flags, depending upon the result, the flags are affected. Keep that in mind. And they are affected automatically. Means you can say that these are like human beings sitting inside and they are actually observing the result. Okay, and as per their definition, if everything becomes okay, as per their definition, if the things are going on, they will change themselves. Okay, let's, for example, I'll explain the first one. So the seventh one. Okay, so that is represents S flag. S flag means sign flag. Okay, S flag stands for sign flag. So what this flag is doing, so this flag will only observe the last bit. Okay, listen very carefully. This S flag bit, what it will do, it will only observe the last bit. Okay, and if it is observing the last bit, then last bit will be either 1 or 0. Yes or no? I hope I am correct. So if it is observing only one bit, that bit result can be either 1 or 0. I hope I am correct, guys. Yes or no? Yeah. So if that is 1 or 0, means if suppose if it if there is 1, it means the result is negative. Keep that in mind. Okay. Means if sign flag is observing the last bit, and if that bit is 1, means the result will be surely negative. Okay. And if the result is giving as this last bit is 0, means the number is positive. Okay, now if you just remember what was the numbers we have taken two numbers, that was 30 and minus 40. I hope you, yes or no, and you only tell me if I go and add this number, I'll get what? Minus 10. Yes or no? Yes or no? So so according to sign flag also, the result is like that only. Means the nature of the result will be negative. Means, and both things are actually matching also. Means I know that the result is negative, and even the sign flag is telling that the result is negative. How it is telling? By observing the last bit. Okay, so if you look at the definition part in this PPT, if I show you, I hope you guys can observe. If you just try to follow me, you will actually understand. I'll erase this part. Just okay, you just follow my marker, then you will understand. So what is sign flag? This flag is used to know whether the number is positive or negative. Yes or no? So this flag is very very important. Means if you look at the result, and this flag is very very important. Why? Because it is capable of finding whether the number is positive or negative. And how it is doing that? 2 points are mentioned here. Look here, all of you. So this B7 means bit 7. I'm talking about this bit. Okay, I'm talking about B7. This is bit 7. So if B7 of the result, so where is result? This is result. I hope you are getting my point. So this is result. Okay, so if bit 7 of the result is 1, okay, if bit, that only I have written here, you can see here, I will written here 1 na. So if the B7 of the result is 1, the sign flag is set. The sign flag is set. Okay guys, keep in mind, set means 1 and reset means 0. Keep this in mind. Okay, set means 1 and reset means 0. So what is written here? I will repeat once more. If the bit 7 of the result is 1, then sign flag is set. Sign flag is set means in this position you will find 1 there. Okay, am I clear? So S is actually the name of this bit. Keep in mind guys, is S is not stored actually here. What is S here? S is the name of this bit. Okay, and what I can store here, as you know, this is a flip-flop. I can store either 0 or 1. So as per the rule, if the bit 7 of the result is 1, the sign flag will set itself, and the set means it will be 1 there. Okay, and actually that is the meaning is the number is negative. Okay, and that is, and the reverse is this one. If B7 of the result is 0, if B7 of the result is 0, then sign flag is reset. Reset means what? 0 means you will find here 0 present. Okay, now is it clear to everyone? Now is this part clear to everyone? Yes. Okay, then if it is binary of 255, see guys, that one, see that only I'm telling. I mean, is this clear to you or not? Just first confirm me. Okay, now I'm erasing and I'm writing as per your choice. I'm erasing it. Okay, I'm coming as per your question. Okay, let's move to the this one. Okay, so what you are asking, yes, can you tell me now? You are saying that if suppose I have, yeah, I have 255 whose binary is this. Yes or no? Okay, so if you look carefully, I am talking about the result. Okay, I'm talking about the result. Yes or no? What I'm doing? I'm talking about the result. I hope you're getting my point. So, means what you are trying to say is that somehow, suppose I have two numbers, let it be x and y. Yes or no? And the result is coming as 255. Are you saying this? Are you saying this? I didn't get. See, see what I'm trying to listen to me. See what I'm trying to say. Whenever any number is given, okay, whenever any number is given, keep in mind that whenever a number is given, the number is converted into what? Zeros and ones. Okay, so you are saying that if I have number 255, it is converted into this. Yes or no? Now sign flag will not observe this. Okay, sign flag is actually observing the result part. Okay, the sign flag is only observing the result part, means whether a number is stored or not stored, it's not observing that. Once an operation is performed, okay, once an operation is performed, in that case whatever result is coming, it is observing that result part. Okay, keep that in mind. If you are just, yeah, it will not look at the number itself only. Okay, it will actually observe only the result part. Okay na, I hope it's clear. Okay, fine. Now let's move to the next flag. And the next flag was what? Anyone just confirm me? What was the next flag? So we had in the flag register, the seventh we had sign flag. Now what was present here? Can anyone tell me? Zero flag. Very correct. Okay. So let's understand about the zero flag now. So this zero flag is again very interesting. So let's understand about the zero flag, means how the zero flag is giving, what kind of nature it is giving actually. So suppose I have a number, let it be 10. Okay, and I have one more number, let it be 10. Okay, now suppose I'm going for an operation of subtraction. So what result I will get? What result I will get? 0. Okay, so this flag is what it is doing. This flag is a very special flag. Okay, what it will do, it will check the result. Okay, if in the result all values are zeros, then what will happen? this bit will be set. Okay, set means 1. Okay, and if you find any non-zero value here, non-zero means anywhere if you find 1, then this flag will be reset. I hope now it's clear to everyone. Once again, yeah. No, see, sign flag was only checking what? The last bit. Keep in mind. Okay, sign flag was only checking the last bit, whereas zero flag will check all the bits. Okay, it will check all the bits. If all the bits are 0, it will set itself. If any bit is 1, it will reset itself. Am I clear now? Okay, so if it is not clear, let's take an example. So suppose I have this number, okay, and I have the same number again. And if I am doing subtraction, what will happen? I'll get the result as what? It will be all zeros. Am I correct or not? Yes or no? So in this case, what zero flag is doing, it is checking all the bits. And if all the bits are 0, this flag will be actually set to 1. And if suppose this bit is 0 here, so now if I do the subtraction, what I will get? I'll get 1 here. Yes or no? Now if any bit is 1, this flag will be set to 0. Now am I correct? Now am I clear? Okay. Okay. So if you have understood, let's do one thing. Let's read the definition also. If you read the definition of zero flag, you will get a better idea. So if the result after ALU operation is 0, okay, what will be 0? Result. Okay. If the result after ALU operation is 0, this flag is set. Otherwise it is reset. I hope now everyone has understood. Yes or no? Okay. Now let's move forward to the third one. The third one is your auxiliary carry. And this one is really very interesting. Let's first of all understand and then we'll move with an example. Now if you read here, it's written here what? All of you just read once what's written there. So if you read carefully, it's written there during ALU operation. Now I'm not talking about result now. I'm talking about what? While the ALU operation is going on, I'm talking about that time. If carry generated from bit 3 to bit 4, if there is a carry generated from bit 3 to bit 4, this flag is set. Okay, so there are 3 points to remember. First of all, during ALU operation, a carry should be generated. Now where? From bit 3 to bit 4, a carry should be generated. If this line is true, what will happen? The auxiliary carry will be set to 1. And if this line is false, it will reset itself. Is it clear to everyone, the sentence? I hope yes. Okay, so let's understand with an example. Let's understand with an example, that will be better. So if I take the example like this, I'll try to take the example in the way it will be best suited as per the auxiliary carry flag. So I'll take like this. So suppose I have a number like this, okay, and I have here one more number like this, okay. And what I'm going to do, I'm going to perform the add operation. Now if you go and do the add operation, before that I would like to point out all the positions. So this is 0 position, first position, second position, third position, fourth position. These are the concerns of mine. Fifth, sixth and seventh position. Now let's see. When I go for addition, 1 plus 0 will give me what? Sorry, it will give me 1. 1 plus 0 will again give me 1. Now this 0 and 1 will give me 1. Now this 1 and 1 will give me what? 0. Yes or no? And there will be a carry from 3 to 4. I will get a carry here. Yes or no? So as per the auxiliary carry flag, it is observing this operation going on, and as soon as it will see a carry from bit number 3 to bit number 4, it will set itself. Okay, so here I'll get 1 0 0 1 1 0. There is again a carry from here. Okay, so if you look at the result, now auxiliary carry flag is not actually concerned about the result. What it is concerned of, it is only concerned about what is going on at this position. Okay, whether there is a carry from bit number 3 to bit number 4. Okay, so if that is true, it will set itself. If that is false, it will reset itself. I hope now it's clear to everyone. Just confirm me guys if it is clear. Okay, I hope it's clear to everyone. Okay, now I'll erase and I'll move to the next flag. What was the next flag? So if you look at the next flag was parity flag. Okay, now let's understand this parity flag with an example. So what in the parity flag, what happened? Let's take two numbers again. So I'm taking two number like 10 10 10 10. Okay, now 01 11 00 01. I've taken two numbers and I'm going again for addition job. Okay, so in parity flag, what happens? The parity flag is actually now working for result only. It will see the result. So let's find out the result. So 0 plus 0 is 0. 1 plus 1 will give me 0. Carry over is 1. Now 1 plus 1 will be giving me 0. There will be again a carry. Now 1 plus 1 will be 0. There will be a carry and 0 plus 1 will be 1 here. And here again will be 1, 1, 0. 1 plus 1 will give me 0 and there will be a carry at this place. Okay. Now it will look at the result. Okay. And it will try to find out how many ones are there. So how many ones are there? You tell me guys. How many ones are there? Quickly. How many ones? 3 ones. Okay. So is this number is odd or even? Tell me. Is this number odd or even? Correct. The number is odd. Okay. So is this point clear to everyone? Just tell me that how you can get even and odd. I hope I am getting my point. Yeah. So once you have done the operation, you seeing the result, you can find out how many ones are there, and if the number of ones are zero, I mean if the number of ones are even or odd, that you can decide. Okay. That's why I'm erasing now. So let's move to the definition. So if you look at the definition part, what is written here? If the result stored in accumulator, if you remember in the last slide, I just told you that the result is generally stored in the accumulator. I mean, I've just shown you this. If you look at this place, I've written here that result is generally stored in A register. Okay, keep that in mind. And A is also called accumulator. Okay, you might be knowing that. Okay, so the result is generally stored in A register. Okay, so based on that, it's written here that if the result stored in the accumulator after ALU operation contains even number of ones, then what will happen? The flag is set. Okay, and the vice versa, if the number of ones are odd number, the flag is reset. Okay, now what I'm doing, I'm just taking the help of, I'm just showing you some result and you tell me whether the parity flag will be set or reset. You tell me. Okay, tell me the parity flag will be set or reset. So what I have to do, I have to count the number of ones. So there are five means odd number, so it will be 0. And suppose if I make it like this, then there will be 4 ones. 4 means even, the parity flag will be set. So it's very easy. I hope you can understand, everyone can understand this. Yes or no? I assume that you all have understood. Okay. Now let's move to the last one. The last one is your carry flag. This is really very important. So carry flag means what? Let's read first. So during ALU operation. Now again see, this is talking about during. Auxiliary carry flag was also about during only. Okay. So keep that in mind. So during ALU operation, if carry is generated from bit number 7 to bit number 8, please, this is the most important part. If carry is generated from bit number 7 to bit number 8, then this flag is set. Otherwise, it is reset. Okay. So let's try to understand this with an example. Okay. So I'm taking here example. I'm taking two numbers again. So let this be the numbers 1010 0101. Okay. I'm again taking two numbers here like this. Okay. Now if I try to go for addition of these two numbers, if you look carefully here, what is going to happen? 1 plus 0 will give me 1. Yes or no? This will give me 0. 1 plus 1 will give me 0. There will be a carry here. then this will give me again 0 here, again I'll get a carry. 1 plus 1 will give me 0, again a carry. 1 plus 1 0, there is a carry. Here I'll get 1, and this 1 and 1 will give me 0, and there will be a carry here. Yes or no? Okay, and if you look carefully, that if I try to show you all the positions, so this is your position number 0, position 1, position 2, position 3, position 4, position 5, position 6, position 7, and this is position 8. Okay, so as per the definition, if a carry is generated from bit number 7 to bit number 8, so you can observe very carefully that bit number 7 to bit number 8 there is a carry. Yes or no? Yes or no, guys? I hope yes. So if there is a carry at bit number 8 from bit number 7, that means the carry flag will be set or reset. Set. That's correct. Okay. Yeah. And suppose I am just making the change in the question. I am putting here 0 here. So 1 plus 0 will give me what? It will give me 1 here, and there is no carry here. So in that case, it will be reset. Okay, so now I assume that every one of you has understood all the flags. Just confirm me, guys. If there is any student, who has not understood these flags, please tell me. I am ready to explain once more. No problem. Yeah, yeah, tell me. Hmm. Okay, okay, I got that question. I mean, that I will try to give you answer some other day, because that also I was getting it doubt there. Okay, so this 255, that's a very good question. I have not analyzed actually this. Okay, this I will analyze and tell you. Okay, this should be the actual question. Okay, so this see actually the question is this, which should be asked here is, if you look at the number, what I said, that suppose anyhow if the result is coming as 255, so if you look at the result 255, in that case all the bits are 1. Yes or no? So if all the bits are 1, then this also is 1. Yes, and sign flag is actually observing this value. Okay, so what will happen? It will tell 255 as a negative number. Yes or no? But that is not the logic. Okay, so this is, you can say, either I will there might be some kind of you can say some extra you can say extrapolation kind of, means they see whenever you find any rule, the rule has some you can say what I'm not getting a word, the like some exceptions. Okay, that will be the best word. So maybe there might be something like that. Whatever be the case, I will analyze once more this part, and I will try to give you the result for this. Okay, already this question already I have written now only, and this I'll clarify in the next class. Okay, this is really a very good question which I have not analyzed till now. Okay, other than this, if anyone is having any doubt, that I'll clarify. Anyone? Oh, okay, that's a very good question. Look here. Now I request everyone to look. So his question is, if you look at the flag register and if you look at ALU, you might have seen the arrow like this. Yes or no? What really the meaning of this arrow is? See here. So what this arrow actually means, that flag register, what it will do, with the help of this it will observe. Okay, with the help of this it will observe and it will update itself. Okay, and whenever ALU wants, it can observe flag register and it can update itself. Are you getting my point? I'll repeat once more. What this arrow means, flag register will observe ALU result or operation going on. It will observe, and based on that it will update itself. Okay, and if required, the ALU can also observe the result and it can update itself. Are you getting my point? Like for example, suppose the I mean, if you look at the carry flag, so suppose I have two numbers, let it be A, B and C. Okay, suppose I have three numbers. So if when I'm adding these two numbers, what I'm getting a result, and that result is having some carry. Okay, so this carry has to be added with this. Yes or no? If you are getting my point, what I'm trying to say. So suppose A and B is added, and suppose the result is generated, and if there is a carry, this carry has to be added with the third number. Okay, so in that case what will happen, the flag register will observe the carry flag, it will take data from there, and it will again add that number to the next coming number, and then it will generate the result. I hope it's clear now. Is it clear now? So why this arrow is like this? Because both ALU and flag register, they are constantly getting updated. Okay. After every operation, they will get updated. They will just observe each other and they will just keep on updating themselves. Okay. So that's why the arrow is like this. So I hope I have made you understood. Any other doubt if you have, just kindly confirm me. Okay, correct. I'll repeat. See, in the program counter, few students have doubt. Okay, but better I'll just show you first the definition of program counter. You can see here the program counter. This PPT I'll drop today in the Google Classroom. So if you look at program counter, the program counter, what is written? Please, all of you just read this program counter. It is a 16-bit special purpose register. It is used to store the memory address location of the next instruction to be executed. What I have observed when I asked few guys to write down the definition of program counter, so what they are writing, it is actually holding the address of current current instruction. Okay, so what you are writing, it is holding the address of current instruction. So please try to understand, this is not correct. Okay, this is a mistake which few students are making. Maybe you also might be thinking in that way, so that it is actually holding the address of current instruction. Okay, it is not like that. Let me make you understand. I hope this few of you are having some in this in the mind, that this program counter is holding the address of current instruction. I hope yes, few of you are thinking like that. Yes or no? Okay, so it is not like that, not like that. Let's understand why I am telling like this. Okay, so let's come to a very little bit clean part. Okay, I'll take this part, I'll take the help of this part and I'll try to make you understand. Now if you look at, I'll explain you the parts involved only. So this is, suppose, your instruction register, this is your instruction decoder. I hope you're getting my point. Okay, and here is your this internal data bus. Okay, and here is your program counter somewhere. Okay, which is stored in the registers part, and here is your memory. Okay, in memory I have two sections, and in the first part address is there, and the corresponding part you will find the instruction here. I hope this diagram is a bit clear to everyone. Yes or no, just confirm me. I hope you're getting the diagram. Yeah, so in program counter, what is there? If you remember what I said, if you want to execute any program, the starting address should be stored in program counter. I told like that. Yes or no? Yes. Now suppose if program counter is having the address, let the address be 1001. Now if you look at this address, can you imagine? I mean, I'm trying to make you imagine. So this 1001 is the address of a instruction which has not yet arrived inside the microprocessor. Am I correct? 1001 is the address of an instruction which is not yet arrived inside the 8085 microprocessor. Am I correct, guys? Yes, it means what? It is not, I mean, see, 101 is present inside, but can I say like that 101 is the address of the current execution? Suppose ALU might be performing some kind of job, okay, and can I say that okay, ALU is performing the job and 101 is now loaded here? Can I say that it is the address of the instruction which is getting processed? I cannot say like that. Okay, but I can say that 1001 is the address of the next instruction, because that once the address is loaded, then only the instruction will flow inside through data bus and will come to the instruction register, and then only it will be processed. Yes or no? So before getting processed, first of all the address has to be loaded, and once the address is loaded, it means it is actually pointing to the next instruction which is going to be executed. Okay, I hope I am correct now. So no one will tell that if you are writing in the exam like this, that program counter is a register which holds the address of current execution, then that is wrong. Why it is wrong? Because you can observe here. Because it is actually pointing to a instruction which has not yet arrived inside. How it can be a current execution one? Okay, and let me make you understand in some other way. If you look here, what I'm trying to say, so suppose there are two instructions which has to be executed. So this is, suppose the second position is 1002. So what will happen? 1001 is loaded here. This instruction I1 will be fetched to instruction register, and after instruction register has fetched the instruction, it will go to decoding and execution. So while this decoding and execution is going on, program counter, with the help of increment decrement register, it will update itself. Okay, and it will now point to 1002. So you keep in mind, while this decoding and execution is going on, at some point of time the program counter will be having a new address. Okay, so if you now, in this scenario, if you look carefully, is 1002 address the address of current execution? Is 1002 the address of current execution? Is it like that? No. So now you are, I hope you're getting my point, that 1002, I mean program counter, is a register which holds the address of next instruction to be executed. I hope you are now I have made you correct. I mean, I have explained you the point. Yes? Okay, yeah, I'm going to erase now. Okay, so with this, I hope this complete 8085 internal part is clear, except uh, except except what? Except this part, and these pins meaning. Okay, except the meaning of these pins, all other parts are clear to everyone. Just confirm me, guys, that you have understood everything, whatever is shown here, and you have understood. Not you have you no. It's not like that you have learned by heart. You have understood everything. Yes or no? Yeah, yes, and in the last class I gave you some videos. I hope those videos were very helpful to you all. If you have watched those videos, yes or no? Yeah, okay guys, so please, if you have not watched those videos, please watch those videos. They will clarify your your doubts, if you have any. Okay, and if you have any doubt there, that also you can ask to me. If I have the answer, I'll tell you the answer. If I don't have the answer, I will accept that, and I'll try my best to give that answer in the next class. Okay, so with this I'm ending today's class, and in this PPT, what is present here is regarding that part which I have not taught, that also is present here. Okay, it will be better you just go through it, and if you want, you can note down the points. Okay, so it's better you note down all the whatever is written here. You can just observe carefully, and which I have not taught, you can just go through. Okay, in the later class we will again try to understand that. Okay, so with this, I hope everyone has understood regarding the flag registers. Okay, and those who don't know about conversion from binary to hexadecimal, decimal to binary, and reverse, then please, it's a request you try from some website and learn it. This should be very clear to everyone. Decimal to binary, binary to hexadecimal, and reverse, hexadecimal to binary and binary to decimal. Everyone should know this. Maybe in the exam you may get 1 or 2 marks question of this also. Okay, or maybe, I mean, in future when we are solving some numericals, these may be required. Okay, because every time if you look at a value, we are going to point with the help of hexadecimal, but when we will going to execute, or when we'll try to understand, we'll move to binary or we'll move to decimal. So this interchanging, it will be used everywhere. Okay, so it's a request that please all of you try from some website. If you are not understanding, you can tell me, I can give you a link from where you can understand these topics. Okay, so with this, now I'm ending up today's session, today's class, and thank you.